Everybody, welcome back to another fun and exciting pre-calculus class. Today we're going to be jumping into lesson 9.3, operations with complex numbers and de Moivre's theorem. Okay, before we can get, I know you're all waiting for de Moivre. I mean, that is like, what a cool name, and you want me to get to that. I get it, okay? But before we can get to it, I'm not going to get to it in this video, I'm sorry. We need to understand the operations of complex numbers. How do we multiply? How do we divide? How do we square? Stuff like that. So before we can get into de Moivre's theorem, we need to be able to handle the basic operations. So that's what we're going to do in this lesson. Next lesson, I promise we're going to get there. I know you're excited about this, so hang in there. All right, so what we're going to do, look at page 183. In page 183, if you really want to confuse yourself, I mean, if you want to go like flat out, full-blown confusion, read that paragraph. I mean, that's exciting right there. So multiplying complex numbers, R1 cosine theta 1 plus R1 I sine theta. Wait, what is, I only got through the first line and I'm confused already, right? And so look at this, man, it's very confusing. So what are they trying to say right here? Here's what they're trying to say. When you're multiplying complex numbers, it's complex, it's complicated. So the way to do it is to learn or to use this kind of like theorem right here, this kind of formula. What you do is you plug in the number. So here's the number they give you. This is the trigonometric number that they give you right here. And then we're going to kind of put it into, it's going to go back into a formula that's going to kick out the answer to you. And you can go through that whole thing if you want to, and you can see how they group it. You can see how they do everything. This right here is what's called the delineation of the formula. They're showing you how they develop the formula. You don't need to know it, all right? You just need to know the formula. So focus on this. Focus on table B, and you're going to be fine. Okay, so let's look over here at the computer, and this right here, this part at the top, basically all I did was rewrote table B. Okay, so I just took table B and put it there onto the computer so that we can have it for reference. Now, take a look at this. This is what they're going to give you. So this is the given, right? This is what the problem gives you. It says, hey, 7 cosine, whatever it is, okay? And then they put it all the way through. This is going to be what you're going to use to convert it. So take your given information and put it into this right here, and then from there, then you can work it. This is the form that you need it to be in order to multiply it, okay? And that's that on page 183, that's that delineation of the formula. It gets it takes it, and this is all that mumbo jumbo right here where you just kind of skip all that and put it straight into the form that they're looking for, okay? So notice where it says the formula will always give you a trigonometric answer. Pay attention to what they're looking for. You may have to convert it back to standard. So if they give it to you in standard, you're going to have to put it in trigonometric to get it into the formula, and then you might have to convert it back if they're looking for a standard answer. Just whichever way. We know how to do that from the last lesson, so it shouldn't be too big of a deal to convert it back and forth. Okay, so here we go. Here is example number 1 on page 183. Now, what they want you to do is they want you to multiply this out, right? This is the and, I guess, is the multiplication. They're just saying find the product of. I didn't write that, but it says in the book, it says find the product of this and this. Okay, so we want to multiply these two. So we're going to use this formula right here. We're going to convert it into that formula. Okay, now look at this. This A and B right here is different than this A and B right here. And maybe you can see it and maybe you can't. These are the R's. Okay, and these are the thetas. Okay, these are the hypotenuse from right there, and these are the thetas from right here. So that's what's going on there. So be careful that you can differentiate between those A's and B's. the first A and B, that's going to be your numbers that are out here. Let's kind of like label this. So this is going to be A and this is going to be B. Now, these two are going to be your alphas. Okay, that's not an A, that's an alpha. And I know that's hard to see the difference, but let's, try to do it. We'll call these the alphas. I'll make a tail a little bit longer on those ones. And these ones are going to be the betas. And I'll kind of make them with capital betas there. Okay, so these ones are going to go here. Okay, so let's go ahead and do that part. So we have 4 times 2. And then we have the cosine of alpha. So that's the cosine of 300 plus b, so 30, parenthesis, there we go, plus imaginary sine of alpha, 300, plus beta, 30, parenthesis, bracket. All right, so that's important to remember that you have to put the R, the regular letter there. It's just a little confusing, not super confusing. Hopefully we've been using alpha and beta enough that you do know the difference there between the two. So the Greek letters are the angles. The English letters, I guess, not really English, but the English letters, there are the R, so the multiplier that's out front. Okay, so once you get into this format, now we can just start solving things. So we're going to start solving stuff. So there we go. That's 8. Then we got a bracket, and we can solve this, right? So cosine 330 plus imaginary sine of 330. Okay. Now, again, that gives it to us when we do that, when we put it into that, it gives it to us in what? All right, it gives it to us in trigonometric form. We're done. Believe it or not, we're done. That's the answer. Now, technically, we would redistribute that, and so we'd get 8 cosine. But let's look back at the book and see what it says to us. It says right here to leave the answer in standard form. How dare they treat us that way, right? Oh man, so what do we have to do? We have to come back over here and we have to put this into standard form. So how are we going to do that? Well, I would go ahead and distribute this, and I can distribute it just by kind of erasing a little bit here, making some room. So we'll call that plus 8. And so we put the 8 to both of these. Okay, and now what we want to do is we want to solve this. What is the cosine of 330? You can use your calculator there. That might be easiest for you. So just hit cosine of 330, and let's see what this thing is. It is square root of 3 over 2. Okay, so that's going to give us 8 square root of 3 over 2. 8 times square root of 3 over 2. Okay, and so this is the first part of it. This is the, I guess, the real number. And then we're going to get plus, here's the imaginary number, right? So we're going to get 8i, and then we need to solve this. Come back over here to your calculator, and now we need the sine of that. So clear that out. We'll hit the sine of 330, and that's going to give us -1/2. So -1/2, okay? Now, we still don't have it quite in the format that we need to have it in. And what you just need to do is you just need to solve these, okay? So if we put that over, we'll just reduce that, and that'll give us 4. So that gives us 4 square root of 3. And here we would just multiply this out. This cancels to a 1. This cancels to a 4. 4 times 1, or 4i times 1 is 4i. 1 times 1. So 4i over here. And that would be, actually, that's a negative. Sorry, there's our negative sign. Almost missed that one. So there we go. That is our answer. 4 square root of 3 minus 4i. Not too bad, right? You're like, wait, what'd you just do there? Watch it again if you missed it. Okay. Now what we want to do is we want to go back to page 183, and you'll see at the bottom, we have when you need to divide complex numbers. And so here we go. Here's our, basically, here's what we need to convert it to. So here's the question, and this is on page 184. This is example number 2. Remember, we need to identify what we're looking at. So this is the A, and this is the B, and this is the alpha, okay? And this is the alpha, and this is the beta, and this is the beta, okay? So now we just need to go ahead and plug into that little formula right there. So we have A over B, so 4 over 2. And then we have bracket cosine of alpha, 300, minus beta, 30. Yeah, same alpha and beta there. That's good, easy. And then we get the plus, and then we have the imaginary, and then we have the sine of 300 minus 30. And then we have our closing bracket. We're just going to do this now just like we did. So 4 divided by 2 is going to give us 2. And then this is going to give us the cosine of 270 and plus the imaginary sine of 270. And now again, we just go ahead and solve this out. And you might be thinking, wait a second, I thought this was a division problem. What's happening right here? Here's the division right out front, right? All right, so the formula that we use, this is where the division is happening. Don't worry about division here. We're not putting it in a fraction or anything like that. The fraction happened out front. So that's where the division is coming from. Okay, so we actually did divide it. We divided 4 by 2. And then we, that's where our 2 came from, is that was a division, not a multiplication. On the first one, remember when we multiplied, it became 8. This one we divided, it became 2. 270 is our number. So we're going to go to our calculator and we're going to find the cosine of 270. So clear that out. Cosine of 270 equals, it's 0. So 2 and then 0 plus I, and then we need the sine of 270. So sine of 270 equals -1. Okay, -1. All right, so now we just kind of need to rewrite it. So we're going to distribute this to it. 2 times 0 is going to be 0. And so this is like our this is like our real number here is 0. So you kind of don't even need to write that, right? And then we're going to, multiply the 2 down here. So we're going to get -2i, -2i. Best way we could write that is we don't even need this, right? We can get rid of that. So -2i would be the correct answer on that division problem. Okay, last thing what we're going to look at in this lesson is we're going to go ahead and do example number 3, which wants us to simplify this problem right here. Notice that we have a squared. All right. The other thing to notice is that we don't have an A and a B, and we don't have an alpha and a beta. We have an R and we have thetas. So you might think, oh, we're not going to get an answer for this question. Well, maybe we will and maybe we won't. We'll see. This is kind of like a literal equation, right? With just letters with no numbers. Remember, sometimes those will work out for us. Sometimes they won't. So we'll just see what we get. Let's just plug in stuff and see what happens. So let's plug this into the formula. So if you look back at table B, you can do that. That's on page 183. While I'm doing this, we're just going to kind of fill in everything. So our A is going to be R, and our B is going to be R. So we're going to have R times R. So it's going to start it off. And then we'll have our bracket. And then we're going to have the cosine of theta, which is our alpha. And we're going to have that plus our cosine of our other theta, which is, again, just theta. Our beta is theta in this case. And so this goes in a parenthesis right here. And then we add and this is the imaginary side. And so we add the imaginary sine of theta, which is our alpha, plus our beta, which in this case is theta again. And we put that there. And now we just start combining our like terms and multiplying what we can multiply. So look here, we can do that, a little bit. That gives us R squared. And then we could do this. So we could do the cosine of theta plus theta gives me 2 thetas, and then plus the imaginary sine of 2 thetas. That should be a bracket there at the end. Okay. Um, Now, I mean, here's kind of the thing. That's about all we can do to it. But it doesn't say on this one which form that it wants it in. So we'll go ahead and leave it in trigonometric form. We can't really, without numbers there, we're going to struggle to get it into standard form. So we'll just leave it right there. There's not much else we can do with that one. That one is just like a warm up. Okay, that one's just like showing you how to square something. You would just, instead of using an A and a B, you just use theta. Theta goes in both spots, and the R, instead of using an A and a B, you're just going to use the R in both spots. And so that's just kind of a warm up for that, because in De Moivre's theorem, we will need to square things and we'll need to do multiplication and division and those kinds of things. So very important. If you missed anything there, if you didn't understand some of that, make sure you go back and watch it again. Check your book, go through the examples again. Do this. Actually, make your hand do it in your notebook. Practice this so that you can be ready for the next lesson when we introduce De Moivre's theorem and we're working with this. All right, well, that's all I have for you. Hope you learned something. We'll see you later. Bye-bye.